Welcome to week 15 of 16 weeks of SATs. Now, this week we're going to be covering quite an important topic, which is multiplying fractions by whole numbers. Okay. Now, from doing all the little bits of research that I do to find the questions, normally in all of the SATs papers, you're going to get at least one of these questions, maybe two. So it's worth knowing how to do this because, like I've just said, you're going to need to score 1 or 2 marks, which is going to help you. And they normally come at the end of the paper. So normally by then we're a little bit fatigued. So it's really important that we know how to do this strategy. So the thing with this question type is, although it's one question type, which is multiplying fractions by 2 whole numbers, there's 2 slight subtleties to it. The first variation is where we have a normal fraction, a standard fraction, like 5/6 multiplied by 40, for example. So we have a proper fraction multiplied by a whole number. The second variation is where we have a mixed number. So that might be 1 and 5/6 multiplied by 40. Okay, so there's 2 subtle variations there that we need to understand and that we need to get familiar with encountering because they will crop up in the SATs papers. Okay, so that's exactly what this video is all about, making sure that you know how to attack the more simple version and some of the tricks around it, and then how we attack the mixed number version as well. So dead straightforward, and with a little practice from this video, you're going to be able to do that. So standard. Into it, I'm going to give you a few examples of my own. We'll run through the strategy and some examples, then we'll drop into some SATs questions, and then I've got some practice questions for you to get on with yourself. Okay, so we're nearly there with SATs. The only thing I ask in sort of payment is that you like this video on whatever platform you're watching it, and please subscribe to the YouTube channel. It really makes a difference. It helps me notify you about the videos and other content, and it helps me make more of these videos. So that's my only plea for now. We're going to get straight into the content, and we're going to master how we multiply these fractions and mixed numbers by whole numbers. Let's get into it. So let's get straight into it. So let's just look at the types of questions that we're going to see. So for instance, the first question type, we have a proper fraction times, do this in blue, a whole number. Now this whole number could be anything. It could be from the number 1 or 2 all the way through to 200, 300. Now these first sets of examples, which is typical of the SATs, is where we have a fraction. Oh, we've just unhighlighted that. Where we have a fraction like this, a proper fraction times a whole number. And this whole number tends to be quite large because this fraction is fairly straightforward. And it just sits exactly how we used to do these ones, where if it was 4/5 times 2, we would just multiply the numerator by 2. Okay, so it's still exactly the same here. The only difference is we're now multiplying by a larger number. Now, all this really wants us to do, okay, is that this number here has been chosen for a reason. This number here has been chosen for a reason because essentially it's in the 5 times table. So when we come to divide, then we'll get a multiplication factor and a division factor. All right. So I'll just talk you through this one. So straightforward process. If we were to rewrite the problem, and forgive me for not using the squares because we'll run out of space, but if we had 4/5 times 200, then this question type would be where we need to multiply the numerator by the whole number. So let's just put them together in the puzzle of we would multiply the numerator by the whole number. Okay, so that's going to give us quite a large numerator, isn't it? So that's going to give us 800/5. Okay, now what a lot of people, so there's 2 situations here. 800/5 is fine, and technically we would get that as a mark, but we would want to be able to transfer that into a proper fraction. This is an improper fraction, so we don't really like that. So really, to solve this problem, we're just going to do how many 5s are in 800. Now, really at this point, what a lot of children would do is they would go into not a long division, a short division. So the bus stop method, and they would do 5 into 800. Now that's fine. Okay, that's absolutely fine. If you want to do that, that's fine. You could do 5 into 800. Let's just do it short. And you would get the correct answer. So 5 into 8 goes once with 3 remainder. 5 into 30 goes 6 times with no remainder. And then we'd have nothing happening at the end. So we would have 160. Okay? So that would be the straightforward way of doing it. The answer would be 160. All right? So that is equal to 160. The other way to think about it is just to think, right, well, I could do this mentally as well, because if we use our known facts, let's just have a quick look at this and go, right, well, what's 5 into 80? All right, let's just forget about this 0 for now. Well, I know that 5 into 40 is 8, so I can double that, because double 40 is 80, and know that that would be 16, wouldn't it? So there's 16 5s. Let's use a pen. There's 16 5s in 80. So make that 10 times bigger by bringing this 0 back. So that's 160. So we can use our multiplication facts to find the answers, or we can go into a short division to know that the answer is 160. Now, ideally with these questions, they want us to produce the whole number. So let's just be clear. I've just double checked. So a little recap. I've just double checked the mark schemes. And it's important that with these questions, we must convert them to the whole number. So the whole number is really, really important. Okay, this is the answer. All right. The mark scheme particularly says do not accept. So it's not going to accept this fraction. Okay, it's not going to accept it. It wants you to do. So this is no good. This is part of the process, but this is the answer that we need to type into the answer box. All right. So let's have a little bit of a look at another question. So again, we see multiplication of a fraction by a whole number. So we're going to make sure that we multiply the numerator multiplied by the whole number. So that's very, very straightforward. So we have, in essence, 1,200, over 3, which is great. Okay, now again, we could drop into a short division. That's fine. So let's do that process, because some of you might feel comfortable with that. So we would drop into a short division. We'd have 1,200, and we would answer that. So we would do 3 into 1 doesn't go. 3 into 12 goes 4 times, and then there's nothing remaining. So that's going to be 400. So again, that would be the answer. But again, we could look at our knowledge factor, our multiplication facts up here and go, right, I'm not really sure how many 3s are in 1,200, but I do know how many 3s are in 12. We can forget about these for now. All right, and we can bring them back into the answer shortly. But I know how many 3s are in 12. That's 4. Now bring the zeros back in. So that's going to give me 400. So this would be the answer. Okay, we've found the answer here, but this would also be the answer here. Now with this, you could say that you could worry that this number is going to be something that you don't really find comfortable working with. But as I said, these numbers, the people who write the SATs papers have produced these numbers here so they are divisible easily by this. So you can use your multiplication facts. Look, you can see here already, 5 is in the 20 times table. All right. It's not the 20 times table, but 20 is in the 5 times table. 60 and 6 and 600 are in the 3 times table. So it's going to work out that you can then divide them very, very easily. So although we get this really large number of 1,200 divided by 3, we can quite easily convert that by just using our known facts and going, right, we don't need to worry about the scary 1,200. I can just see 12 in there. I'll bring these zeros back in shortly, which is multiply by 10, multiply by 10, and we get to this situation very easily. Let's take a look at a few more examples. So again, if we go straight into this problem, so again, we see the multiplication, don't like the red, we see the multiplication of a fraction, so we know that we're multiplying the numerator by the whole number. All right, so very, very simply, we're going to do 3 times 250. If you can't work that out in your head, you may need to do a short multiplication to get that. But in my head, I would be partitioning, and I'd be going, well, 3 times 200 is 600. Wrong colours, that's annoying. Is 600, and then 3 times 50 is 150. So that's 750. So we basically get to 750. over 5. And we go, right, okay. Can I do that mentally? Well, I know that if I know my 5 times table, I know that 5 into 60 is 12. So I could count on from that very, very easily and get to 75 by adding on 3 more 5s. Very simply, that's going to be 15, isn't it? So again, we would bring the 0 back on. So essentially what I'm saying is that's a hundred. So we've worked out how many 5s are in 75. That's 15. Forgot about the 0 for now, but then when we've got 15, we're basically bringing that 0 back so that we get 150. If we were to do a short division, let's just do it to prove it. 5 into 750. I haven't used my ruler, but how many 5s are in 7? Well, we've got 1 with 2 remainder. How many 5s are in 25? 5. And there's nothing to happen at the end, so we've got 150. So again, it's important that this is the answer. This isn't going to be accepted from the mark scheme. It says do not accept. So it would not accept 750 over 5. It wants you to convert to the whole number. All right. So again, we've got this next question, 3 over 6 times 300. Now, essentially, what we've got with these multiplication questions is basically this is saying of. So if we were to take a little bit further, this multiplication symbol is saying 3/6 of 300. So if we understand our fractions as well, we can go through this process, but 3/6 is a half. So all this question is really asking is what is 3/6 of 300? It's basically asking what's half of 300. And you might just know that's 150. And if so, that's the answer. All right, 150. But let's go through the process if you were sticking to a strategy. And this is why knowing this is important, because that's just saved us a lot of time. But now, if you don't, we're going to have to do 3 times 300. So 3 times 300 is 900 over 6. How many 6s are in 90? Some of you may not know that, so you're going to drop into a short division. So let's just do that. So we've got 6 into 900. How many 6s are in 9? 1. How many 6s are... So it's 1 remainder 3, isn't it? How many 6s are in 30? 5. So we get to that situation of 150. So again, it's not the end of the world because we've got to that point very quickly, but we could have got to that point here in literally 5 seconds if we just see that this is saying what is 3/6 of 300. All right. So very, very straightforward. These questions aren't anything to worry about. And again, they can be solved very, very quickly. I'm adding a lot of explanation in, but they're very simple to solve. And again, the final little set, we see the multiplication. So we know that we're multiplying by the numerator and we're going to multiply by this whole number. So 2 times 350 is 700. So that's quite nice. It's quite a nice number. Hopefully you can see that. So we've got 700 over 7. Well, how many 7s are in 100? Sorry, how many 7s are in 700? Well, we should just know that that's 100. But some of you will go into autopilot and go, right, I need to convert. So how many, and do a short division. If you needed to do that, then you would do 7 into 700. How many 7s are in 7? 1. And then obviously you're going to get 0, 0. So we know that we've got our answer. That would be the answer that goes into the blue box on the SATs paper. We've got our blue box. We would be writing 100 in there. We wouldn't be able to get the mark if we just leave 700 over 70. So it's really important that these, whichever way you get to it, they get transferred into the blue answer box on the arithmetic paper. And again, if we go to the final question, we see the multiplication. We know that we're multiplying the numerator by the whole number. But again, it's 1 times 660. So again, that one's fairly straightforward because that's going to give us 660 over 6. Some of you, again, will feel really confident just going, right, that's great. I need to do a short division, 6 into 660. You're probably seeing the answer already. How many 6s are in 6? 1. How many 6s are in 6? 1. There's nothing to happen there. So our answer is 110. And that is what would go in the answer box. This would not. We don't want that in the answer box. We want this. So essentially, that's how we solve these fractions by whole numbers. The next ones we're going to look at is how we solve mixed number questions. So with this strategy, I ummed and ahed as to whether we would do, there's two ways that we can do this, but I'm just going to show you one way, which is my preferred method, which I think is fairly straightforward. The key bit is understanding here that we have two parts of this problem. We have the whole number here, and we also have the fraction. And all we're going to do is we're going to multiply 60 by both parts, okay? So what I mean is we're going to do 1 times 60, and we're going to add them together at the end. So we're going to do 1 times 60 equals 60. So we know that that's there, which is the green part. And then we're going to do the fraction part, which is the part that we've done in the previous part of this video. So we're going to do 2 over 3 times 60, which we know is going to be 120 over 3. And at that point, again, hopefully we can see our known facts in there. We can see the 12, we can see the 3. So it's going to be, how many 3s are in 12? Well, it's 4. So it's going to be 40. Yeah. But if you wanted to do that short version again, you could. So you would do your bus stop. You would do 3 into 120. How many 3s go into 1? Well, there's none. We're going to carry it. How many 3s go into 12? 4. So we get to 40. All right. And then the key bit is we've got 40. All right. The key bit is to make sure that we add this number, this part of the fraction, to this part of it. So this part of the question, we got 60. This part of the question, we got 40. So we need to add 60 and 40 together, okay? Because we've took them apart. So 60 add 40 is obviously 100. All right. So this 100 is the answer, and that is what would be written in our blue box. Okay, so very straightforward. So the process is going, right, I see a mixed number, I'll just multiply the whole number separately, which is normally dead easy, and then we go back into the process that we know of doing 2 over 3 times 60, which is just multiplying the numerator. So very simple. And again, if we just sort of go into autopilot mode, we would just go, right, dead simple, 2 times 30. So fabulous, that's 60. And then I'm going to do 1. Oh, got quite a large line there. Then I'm going to do 1 over 5 times 30, which gives me 30 over 5. Dead simple. How many 5s are in 30? Well, that's 6. So I've got my two parts, which are this, which is this bit. And then I've got this, which is this bit. Now I'm going to add them together. 60 add 6, obviously dead simple. Let's get a pen. 60 add 6 is obviously equal to 66. So this is both parts coming back together, and that would be the answer. So 2 and 1/5 times 30 is 66. So that would be the answer. So again, very, very simple. And I think with this way, there is the other way where we could multiply the denominator by the whole number, add the numerator to create an improper. It gets messy. With this, it's just keep it simple, and we know how to do this bit, add them together. And again, so it's dead straightforward. 1 times 40, so this is the whole number, is going to give us 40. Then I'm doing 3 over 6 times 40, which is going to give me 120 over 6. And again, we should be able to see that that's going to give me, how many 6s are in 12 when there's 2? So we're going to get 20. But again, if you need to go to a short division, so again, the answer, before we do the short division, is this part and this part. So we can see that the answer is 60. But again, if you couldn't get to 20 down here, you would have just done 6 into 120. 6 into 1 doesn't go, carry the 1. 6 into 12 is 2, 0. So again, we're getting to the same situation of 20. We've got 40. We're going to add that together. So the answer would have been 60. All right, let's take a few SATs questions. So again, some of the simpler processes. So again, I always like to rewrite the question just as a matter of habit. So we've got 2 over 3 times 900. So again, that's going to give us 1,800 over 3. And again, if you were struggling with that part, again, you know that we're multiplying the numerator. If you were struggling, well, what's 2 times 900? Well, what's 2 times 9? 2 times 9 is 18. Then we can bring those zeros over. Essentially, all you're doing there is dividing by 100 times by 100, in essence. And again, we can utilize that here as well. So how many 3s are in 18? Well, there's 6, isn't there? Bring the hundreds back. We're going to end up with 600. All right, so that should technically be our answer. If you were at this point and you weren't sure and you needed to do 3 into 1,800, well, you could have done that. 3 into 1 doesn't go, carry the 1. 3 into 18 is 6, and then those zeros are going to carry over. So the answer would have been 600. Very, very straightforward to do. And again, the purists, or if we're looking at this mathematical knowledge, really all they're saying, what's 2/3 of 900? We can see that 3 goes into 9. How many 3s are in 9? Well, there's 3, but we only need 2 of them, so that's 6. So again, a lot of you will feel more comfortable just going through the whole process, but really we can see these questions just be like, well, it's 600. Let's have a look at another example. And again, hopefully you can spot 6 into 54. So we know that how many 6s are in 54? Well, there's 9. Okay, let's see where 9 plays out. 9 times 5, 45. But let's just see it. So 5/6 times 540. So the issue here is we've got to do 5 times 540, which is quite tricky. So again, that table's knowledge up here of just being able to look at this and go, right, forget about the 0 on the end and be like, right, these parts here are the key parts. So you basically be going, how many 6s are in 54? Because remember, this means of. All right. So what's 5/6 of fractions of amounts? I'm going to do this in different color again. 5/6 of 54. So basically, it's just how many 6s are in 54? Well, that's 9. Yeah. 9 times 5, which is the numerator, is 45. So this is going to be 450. Very, very straightforward. But we would need to do a lot of work around this to get there. So let's have a look. Let's say a lot of you wouldn't have been able to do 5 times 540 mentally. So you drop into this, which is fine if you can do it quickly. Just going to get my ruler. Because this is what a lot of you might have to do. 5 times 0 is 0. 5 times 4 is 20. Carry the 2. 5 times 5 is 25. Add the 2 is 27. So then we're at basically 2,700 over 6. And let's go through the process. So we're going to do 6 into 2,700. So how many 6s go into 2? How many 6s, as I just said, how many 6s go into 2? Well, none, so we're going to carry that. How many 6s go into 27? 4, because that gets us to 24. Remainder 3. How many 6s go into 30? 5. How many 6s go into? So that's going to be 0. So the answer is 450. But we got there up here. I'm just going to change it to green. We got there up here by understanding that these question types are just the multiplication symbol is basically saying of. All right, so up here, it's probably much easier to do. If we think of 5/6 of 540, if we can spot our, and just think, right, forget about the 0 for now and do 6 into 54, that's much easier mentally to do, because 6 into 54, how many 6s are in 54? 9. Times that by 5, we get 45. Bring the 0 back, 450. So our answer of 450, if we can understand that the multiplication symbol in these questions is just saying of, then it makes it much easier. So let's see if this stats question is any more straightforward. So again, I'd be looking at this and thinking, right, if we take the thought process of the previous one and go, right, let's just break this question down into, we've got 4/5 of, it's saying of 40. And essentially going, how many 5s are in 40? Well, there's 8. Multiply that by the numerator. 8 times 4 is 32. Then we bring the 0 back into the equation. So we've got 320. So it's really easy to solve that way mentally by using our known fact. If we were to do it the other way, 4/5 times 400. So we're going to get 4 times 4 is 16. So we're going to get 1,600 over 5. We need to do our short division. 5 into 1,600. How many 5s are in 1? We've got none. We're going to carry the 1. How many 5s are in 16? Well, there's 3 because we get 15, remainder 1. How many 5s are in 10? Well, there's 2. So we get to the same place. All right. So this process of getting to 320 is also very possible to get there using our known facts and remembering that this multiplication symbol in these questions just means of. So again, with this question, we're going to do 1 times 10, which is 10. We can remember that for a little while. Then we're going to do 3 over 4, which is times 10, which is going to give us 30 over 4. Do our short division, which is 4 into 30, which we can't do because that's just 4 into 3 doesn't go. So it's knowing how many 4s are in 30. Well, that's going to get us to 28. Okay, and that's 7, isn't it? Remainder 2. So we've got 7, remainder 2. So we've got 10 and 7 remainder 2, which is 17 and remainder 2. Okay, over 4. All right, so it's 17 and a half. So 17 and a half would be our answer. 17 and 2 over 4 would have been fine. I've just changed that into a half because it is a half. All right, so very simple, very straightforward. Whole number, fraction, the remainder just becomes the new numerator. Very simple. And again, this one could be overcomplicated. So it's basically saying what's one lot of 40 and what's half of 40. So basically, one lot of 40 is 40, half of 40 is 20. So we should get 60 quite easily. But look, 1 times 40 is 40. 1 over 2 times 40 is 40 over 2. Very, very simple. How many 2s are in 40? Well, how many 2s are in 4? There's 2. So that basically gives us 20, doesn't it? So we would have 40 and 20, which is 60. 60 would be our answer. So again, with these questions, they're not actually that difficult. And really mentally, if we think about them and go, right, this is asking me what one lot of 40 and what's half of 40. So half of 40 is 20. One lot of 40 is 40. Add them together, 40 and 20 is 60. So very simple. And these come later on. And like with all of them, there's ways and means that we can complete these mentally without having to get ourselves in a twist. And let's take a look at this final one. So again, we jump straight into it of, just get my pen, 1 times 39. So I've got 39. And then I'm going to do 39. Well, I'm going to do 1 times 39, which gets me to 39 over 4. Very straightforward. And then I'm doing 4 into 39. So I've got 4 into 39. Hopefully you're spotting that's not going to work. So 4 into 39 is not going to go, but I can get to 36, which is 9. So it's 9, remainder 3. So I've got 39 and 9 remainder 3. So I'm going to add them together. That's going to get me 48. And 3, as this 3 becomes the new numerator. And then 4 is the denominator, so that remains. So we've got 48 and 3/4. So again, relatively straightforward. And again, when we get this remainder from the division, don't worry about that. The remainder just becomes the new numerator. Very simple. So you get 9 remainder 3. The remainder 3 just becomes the new numerator. And we were working with fourths, so the fraction, the denominator becomes fourths. Relatively straightforward. And here we've just got a few examples for you to have a go at. So we've got multiplying fractions where the fraction is just a proper fraction where the numerator is smaller than the denominator. And then we've got some of the mixed numbers to have a go at as well. So again, it's worth practicing. And like we said right at the start, you're probably only going to get one of each, one of these and one of these in your SATs questions. So there's 2 marks available, but they are relatively straightforward to do. And I'm sure you will master these very, very simply. Brilliant. So hopefully, I always say, hopefully we're at a point now where you're feeling much more comfortable with these question types of multiplying fractions and mixed numbers by a whole number. Okay, and ultimately from the examples you've looked at, it's pretty straightforward. If you can work with fractions and numerators, you're pretty much going to be able to do that. And the key bit, as we discovered, is very much our sort of known multiplication facts as well. Okay, if we can spot those within that, it's really going to help us. And the people who write the SATs papers make these questions line up with our known multiplication facts as well. So that really, really helps us master these. And at the end of the day, if you tackle the SATs papers in a few weeks and you're only 50% sure about these, there's probably only going to be 1 mark in the arithmetic paper anyway, so it's not something that you need to get yourself overly worried about. So that's it for this week. Next week is the final planned week, week 16. So we've got another fantastic video coming up, and then the likelihood is in just the 2 or 3 weeks in the run up to SATs, I'll produce a few smaller videos just covering some key topics. So please let me know if there's anything else that you'd like me to cover before SATs. I've had a few questions about algebra. I probably won't be doing algebra just because it's not going to crop up. If you're not sure about algebra, well, really we need to drop into BODMAS. There's a video on BODMAS, so check that out. That's probably as much as you're going to need to know for the Key Stage 2 arithmetic test. Okay, so well done for getting this far, week 15. Do the practice questions, and my final request is please subscribe to the YouTube channel. You can see the little logos here, and it makes a big difference for me and helps me produce more videos in the future. So well done for working so hard. Good luck with your SATs in a few weeks, and I'll see you in the next video.